Yes, yes. You remember.
Mhm.
2 more minutes, 2 more minutes.
Yeah, that is what will happen at that. Okay, so okay, those who have come, yeah. So welcome. So this is season 11 and episode 3.
Yes.
So why I said episode 3 is because so today we are going to do the continuation of 2 episodes before.
Six,
So
seven, 8, 7.
so there are 2 sessions happened before this session.
Yes.
So so after that second session, this is the third session we are going to have on week 11. Okay, we will slowly start the session so that the people join. Yeah, today we are going to do the most important one, which is p-value. So usually in statistics, this p-value plays a key role. So until now, we don't know which value to be chosen as alpha or why we are choosing alpha like that. So if you are not a big fan of alpha or the significance level choosing, then this particular p-value will help us. So am I audible clearly?
Yes, sir.
Matlab, voice is clear, right?
Yes, sir.
Yeah.
Yes, sir.
So we are going to look into that p-value and we will solve few problems which are basically from 10.7 and 10.8. So whatever the doubts you have, I can take on the questions. If there is enough time, we will solve each and every problem. Okay.
Okay, sir.
Okay. So let us recall what we did actually in the last session at the end. So what exactly we did is we are trying to test for mean. So we have seen some standard tests, and one important test is testing for mean. So if some samples are coming from one distribution, so let's say something from normal mu 4 square where mu is unknown, and we are trying to predict or we are trying to test our hypothesis. If someone said mu takes some value and we are trying to verify his claim. So that is what testing for mean is. For the testing, we have some setup and the process. So what we do is, so we take some samples. Here they have taken 10 samples, and in between there should be something called test. So what is the test we are going to perform? And there is one more thing called acceptance set. So if you know test or acceptance set, you can you can get the other one. So it's just the opposite of it. So what we do is we have taken some 10 samples.
So somebody
We
can
are
unmute, sir. Somebody should be muted, I guess, sir. Some background noise.
I guess it's from my background only.
Your side. Okay, okay.
Yeah,
Okay.
namaz is going
Okay.
on. Okay. Yeah. Am I audible or is it
No,
the
no,
background
you are very
noise
much
is
audible.
Audible, audible.
You are very much audible, sir.
Audible.
Proceed. Please proceed.
You
okay?
can go on.
Shall I continue?
Yes, yes.
Please.
Yeah.
Audible, audible.
Yes,
No
sir.
problem.
Just continue, sir.
Okay.
Yes, audible, audible, sir. No problem.
Yeah. So there are 10 samples we have taken and we are trying to test the mean. So in order to test the mean, if you have 10 samples, what we do is we calculate the sample mean, right? If you have the 10 samples from any distribution and we are trying to test the mean, what we actually do, we out of the 10 samples, we actually compute the sample mean, which is x1 plus x2 and so on x10 by 10. So this is what is called as a test statistic. So this is a static value. When you have 10 samples with you, this is actually some real value or static value, fixed value. So this particular fixed value, we will take it as T, capital T. So this particular T is called test statistic, where we use the static value in order to perform the test. So what is the test? We actually reject H naught if this particular T, test statistic value, is greater than some C. So C is also some constant. Okay, this is the test. So if this is the test, the acceptance set will be t less than or equals to c. So we are going to reject h naught if this particular test statistic is greater than some c. So when are we going to accept h naught? So that is what the acceptance set is. So we are going to accept h naught when t is less than or equal to c. So all the values which are less than or equal to c will come under the acceptance set. So now we have acceptance set and test statistic, and we have the test also, and now we have to compute the size and the power of the test. So usually we don't find the power of the test. We actually find significance level, which is the size of the test. So significance level or size, both are same. So in order to compute size, we know alpha will be equal to probability that we reject h naught given h naught is true, right? So this is the alpha. So when are we going to reject h naught? When t is greater than c. What is t? So t is actually the sample mean. So alpha will be equal to probability that sample mean is greater than c given. So also, yeah, we have to fix what is null and what is alternate. So null we are going to take mu is equals to 0. Alternate we are going to take mu greater than 0. So even this is the setting. So this is the hypothesis. This is the test. These are the samples coming from one distribution, test statistics, and acceptance set. These are our setting for our problem. And later this is the computation. So we are going to compute probability of type 1 error, which is alpha, which is probability that we reject h naught when h naught is true. So when we reject h naught, when t is greater than c, we reject h naught. So what is t? T is x bar. So these all are connecting steps, connecting things. So you have to identify why we have written
So
like this.
T will always be the mean.
No, not will always be the mean. So here we are testing for the mean. So which is the best static value in order for testing the mean? So if you have a sample and you want the mean, you are testing for the mean. Sample mean will be the best thing to compare with distribution mean,
Okay,
correct?
yes. Yes.
So that is why here the test statistic is sample mean. In other cases, test statistic may be just the sum, and in some other cases it can be the variance. So variance of
How we could specify that, sir?
depends on the
क्वेश्चन में
testing
रहेगा.
we do. Depends on the testing we do. So if you are testing for mean, your test statistic will be sample mean. If you are testing for variance, your statistic will be sample variance, which is s square.
Okay, it will be given.
Depending on, yeah, usually 99.9% cases we will give the test statistic. Okay, but ultimately the test statistic is a function of the samples. Okay, either it is sum of the samples divided by 10, which is the sample mean, or just the sum, or it is the sample variance. Either there are many cases. You can just take something like max of x1, x2, and so on
Okay, you
xn.
mean any function?
Depending upon the testing we do, it depends on the depending upon the testing.
Yeah, it could be any function.
Yeah, it could be any function, but function of the samples only.
Uh,
Okay, here we are testing for mean, so that is why we took our test statistic as sample mean. Okay, now we can compute this alpha. We know that this x bar see this x bar given mu is equal to 0 follows normal 0 4 square by 10, because 4 square is the distribution variance. So the sample mean variance, so variance of x bar is actually variance of x divided by number of samples. So here we have 10 samples. So the variance of x bar will be 4 square by 10. And we have given that condition that mu is actually 0. So it follows normal 0 comma 4 square by 10. So if this follows normal 0 comma 4 square by 10, then x bar minus 0 by root over 4 square by 10 follows standard normal. Correct?
Yes, sir.
correct?
Yes, sir.
Yeah. So it's just x bar minus expectation of x bar divided by variance root over variance of x bar. So it follows standard normal. So that is what we are going to do. So we are going to subtract 0
So it
and
is C
divide it
minus
by
C minus
divide it
0.
by
C minus 0 also. Yes.
yeah, c minus 0 and divide it by just 4 by root 10. This is 4 by root 10 standard deviation. So now what happens? What is this? This is z. And what we got? We got probability that z is greater than some root 10 c by 4. So this is equal to 1 minus fz of root 10 c by 4. Now we got alpha in terms of c. So now what we should do?
So here at so P, so this is Z. So
Hmm.
P of Z greater than C by square root of 4 by square root of 10, right?
Hmm. Hmm.
But how the 10 square root of 10 C by 4? How does the reverse? I didn't
See,
understand that.
this is c by 4 by root 10.
Root
So
10.
what this will be? This root 10 will
C by,
go to the
okay, root 10
numerator, right?
C. Okay. Sorry.
Root 10 c divided by 4.
So 1 minus it will be in terms of FC. 1
Yeah,
minus FZ of square root 10 C by 4. Okay.
root 10 c. See, this root 10 square root is only for 10, not for c.
Yeah.
Okay. Yeah. Now here till here we have reached yesterday. So now we have some c values. So if I take c equals to 0, so this is the values of c. If I take c is equals to 0, fz of the 1 minus fz of 0. So what is fz of 0? So this is probability that z is less than or equals to 0. What is this?
Half.
0.5?
Yes, 1 by 2.
Yeah,
Yes.
half.
Yes.
So when c is 0, alpha will be 0.5. Like this, when c is 1.62, we know how to compute fz of root 10 into 1.62 divided by 4. So this is a value, and we know there is a standard normal table we have. So from there we know the value of fz of this particular value. That comes out to be somewhere 0.9. So when it is 0.9, 1 minus of 0.9 will be 0.1. So when c is 1.62, we just substitute values of c and correspondingly we get the values of alpha. So 1.62 alpha will be 0.1, 2.08, 0.05 like this. So what you observe is, hmm,
Just a quick question, sir.
hmm,
Here, since we have taken mu equal to 0, right?
hmm.
So that is the reason why we are getting this kind of C value. If I take mu something else,
Yeah,
then value will be different, right?
value will be different. It
Okay, so
changes.
this is a standardized value with respect to mu 0
With
and
respect to this particular case only, with respect to samples coming from normal mu 4 square. So
okay.
here it is 4 square, that is why it is divided by 4.
Hmm.
Okay,
Yes,
if
sir. Got
something
it, sir.
variance has changed, distribution has changed,
Hmm.
correspondingly this will change. This inside
Hmm.
term will change.
Correct. Okay, sir.
Okay, depending upon that we get the values.
Okay.
Okay, for standard normal 1.96 I guess is
Hmm.
equivalent to 0.05.
Yes.
Okay, here it is
So,
2.08.
so what sample size they take, sir, when they calculate 1.96? Like
What?
here sample size is 10, right?
Ha.
So what sample size generally they take when they get 1.96?
Usually more than 30.
More than 30. Okay.
Mm-hmm.
So in the term and we'll be given these standard values now, sir. FZ like a
We
table.
will. We
Hmm.
will give wherever in a particular question. If you require the standard normal table value, we will give 2 or 3 values, out of which you have to choose one.
Okay.
So which one you wanted? Okay.
Okay.
So
Yes.
here alpha is equals to 0.05 and 0.01. These are most commonly used things.
So can you repeat that Z thing?
Which one?
That alpha equals to P uh, x bar by 4 by root 10. This thing.
Okay. This is something like standardization, normalization. Okay. So what we do is, if you know that your variable, random variable follows normal some 0 sigma square. So this is for everything, not only this particular case. If you have some random variable y which follows maybe normal mu sigma square, then y minus mu divided by sigma follows normal 0 1, okay, which is standard normal. Okay,
Okay, sir.
so here, yeah, here our variance is 4 square by 10, so we will root it. So we have to take the sigma, not the sigma square. This is sigma square, so sigma will be root over this, and also the mean is 0. So x bar minus mean divided by root over variance will follow standard normal.
Yes.
Okay,
Okay, sir.
yeah. So yeah, so these are very commonly used alpha values. So alpha is equals to 0.5 or alpha is equals to 0.1 actually refers that. So we are okay with getting probability of type 1 error as some 0.5. So if you are okay with alpha is equals to 0.5, what it tells is at the significance level. So this is called significance level. So significance level at the rate some 0.5. So it is nothing but saying we are probability of type 1 error is 0.5. So that means there is a chance of 50% times you can go wrong. So if you are okay with that, we choose alpha as 0.5. So if you are not okay, you are okay with 10% of the cases, then you choose alpha 0.1. So depending upon our uh, lenience, or depending upon our factors, or how convenient we can take, we choose alpha. So most commonly we are okay with 5% of error. So that is why we take alpha value as 0.05, and someone will most of other people will be like 5% is too much, and they will be like at significance level of 0.01. That means 1% of error can happen. So probability of type 1 error, so which is we are rejecting h naught where h naught is true actually, when h naught is true. So this particular thing, probability of rejecting h naught when h naught is true, is actually 1% or 0.01. So so most of the cases we either use 0.05 or 0.01. So finally what we conclude is, this is what we conclude. Z test, so this is called Z test or Z test. At significance level alpha, what we say is we reject H naught if our test statistic value T is greater than C, where C you can fix C. So if you want the significance level alpha at 0.05, so what we say is Z test at significance level alpha 0.05. So we are taking 0.05. So our C value is 2.08. So you reject H naught if T is greater than 2.08. So what we do, we take 10 samples, we compute the sample mean of it, and if your sample mean is greater than 2.08, maybe something you got 2.5 or 2.9 or more than 2.08, what we do is we simply say mu is not 0, mu is actually greater than 0. We reject null and we fix that we are accepting that alternative is true, which is mu is greater than 0. If your test statistic value, if your sample mean is somewhere around 1.5 or less than 2.08, we actually accept null. So we say yes, our claim is correct, mu is actually equal to 0. So we accept that claim. So that is what we do in this Z test. Okay.
Once again, sir.
Okay. And yeah. One more thing is, so whatever C till now we are talking about C, right? So this particular C is called the critical value. Okay. So at what value, if critical, so the word critical itself tells us. So if your test statistic value crosses that critical point, we are going to reject null. Okay. So this particular C So when alpha is 0.5, our critical value is 0. When alpha is 0.1, our critical value is 1.62, like this. So when alpha is 0.05, our critical value is 2.08. So C is referred to as critical value. Okay.
Can you scroll up for a second, sir? Just fully, little bit more. I just want to see the normal one.
This one, no?
So by
Why
using
we see
alpha,
the same
we
one,
choose
normal
C,
zero.
right?
More cases, people, if they don't know the p-value, if there are people not interested of p-value, what we actually do is, I will compare both. So what we actually do is, we fix alpha and we find the critical value.
Okay.
Okay. But after finding the critical value, what we do, we find this test statistic value. And looking at the test, if it is t greater than c, you are going to reject h naught. You just compare t, your test statistic, with critical value. So if t is greater than c, you are going to reject. If t is less than c, you are going to accept. This is what we do.
And sir, that table we have to find by ourselves.
Which table?
That C alpha table.
No. See, if we give you alpha, you know how to find c, right?
Uh,
So that is what you have to do. So we have taken different cases. That's it. Okay. So G tests are always performed with some significance level alpha, which we will give you. Okay. We ask you to compare, to test the mean at a significance level of 0.05. So usually if you see the questions also, you will find alpha value is given at every place. Okay. Using C alpha value, you find the value of C. Okay. So this is one way if you don't know the p value. So
Sir,
once
can I
you
ask
know
a
the
question, sir?
Mhm.
Sir, we'll be given alpha values, and from alpha values, we'll be calculating the value of C.
Hmm.
Right. So, like, how do we know that, like, 2.08? Like, how do we know that we are going to reject for 2.08 or whatever C that we're going to get? If we are not given the value of C or the standard against crossing which we have to reject, how do we reject?
If we have given alpha, so what you have to do is, you simply have to do, okay, so here let me take, so we got alpha is equals to 1 minus some fz of root 10 c divided by some 4, correct? So if alpha is known, suppose alpha is known, what we do, we bring this fz root 10 c divided by 4 is equals to 1 minus alpha, and root 10 c by 4 is something like fz inverse of 1 minus alpha, correct? So c will be something like 4 by root 10 into fz inverse of 1 minus alpha, where alpha is known. So if you know this, you know 1 minus alpha. If you know this, then you know this value. We know the fz inverse values also. Do we or no? Do we know this?
I
Sir,
can't say, sir.
normal table from normal table, sir, inverse normal.
Yeah, for normal table. See, if we will give you the normal table also. Okay, maybe 0 0.1, 0. There will be 1, 2,
It will be
3.
better if you can explain FG inverse, sir.
See, fz inverse is something like inverse function of fz table.
We require to see the same table, sir, for that.
So
Same
how?
table you can see from it, from the same
Yes,
table
sir.
only,
So
right?
how to read off the value, sir? From FZ for FZ inverse from FZ table.
Okay, for that I just have to open the table. Okay, just a second. Huh?
Sir, yeah.
Let me share the screen. Is my screen visible? Z table screen. Hello?
Yes, sir. Yes, sir.
So can you please zoom a bit?
Zoom? Yes, sir. Zoom
Yes,
it a
yes,
bit,
I
sir.
will zoom. Okay. Is it better now?
Yes, sir. Better, sir. Better.
Still you want zoom?
Yes, sir. If
okay.
you
No,
can,
no, it's okay.
if you can, sir, please.
It's okay. It's okay. It's okay.
Now?
ठीक है sir.
Okay, yeah. So this is the Z table we know. So you see how to read this. This is exactly at 0.0, which is at 0. Correct? The probability. So this gives you probability that Z less than or equal to 0. This is called 0.5. So 0.5 is the value of probability that Z is less than or equal to 0. And this is the probability that Z is less than minus 0.01. So probability will decrease. Correct? So you see. So this is negative Z score table. So usually we give you, which table we give you? Positive Z. Positive Z, okay. Okay, there is positive one. So
Let's see the position.
let's see the positive then. You will get clearer. So positive means you have to remember that all the values inside it will always be greater than or equals to 0.5. Because half of the area will always be covered in this, like this. So whatever the values you are going to see, that will be the right side of the y-axis. So the left side of y-axis will cover 0.5 area. Correct? So this is the probability that, so if I pick random value like this point, you see this is 0.82639. Okay. So this is actually the probability value. Correct?
Yes, sir.
Yes, yes.
For which value this probability is?
0.94.
Sir,
Point-
0.9
0.94.
0.94. That means fz of 0.94 is 0.82639.
Yes.
Okay.
Mm.
So what will be the fz inverse of 0.82639?
Okay, 0.94.
Yes. So that is what it will be. So in order to find fz inverse, you look at the value inside fz inverse. Suppose it is something like 0.75. So you just have to go to 0.75 in your table. So where will this 0.75 come?
0.68.
0.68. So fz inverse of 0.75 is 0.68.
Yes.
May I ask a question here?
Yeah.
When we actually compute the probability, we are saying probability right now, let's say, not let's say, basically we are saying if it is greater than C, we reject the null hypothesis. And we also have said that we have this 1 minus fz of whatever be the value. So the probability when you compute, the probability of not finding, or rather finding null hypothesis to be true is what we are computing, or how is that?
No. We are just computing.
Or did I get something mixed up? I just want.
See, here it is. So your doubt is why this 1 minus coming into the picture, right?
Because yeah.
So here this is probability that z is greater than root 10 c by 4. Okay. Correct? From here to here it is okay.
Yes.
Now you see, we don't know how to compute when it is greater than symbol. We convert it into less than or equals, right? We convert it into CDF form.
Yes.
So what we'll do? 1 minus probability of z less than or equals to root 10 c by 4.
Correct.
So what is this? This is basically this.
Yep.
So that is how this one comes into the picture.
So in the Z table that you saw, we know the value of left side.
So
Then 10 by 4 into C is the left side from the Z.
We know the value of
Z left side from the Z on the like table that graph you showed on the then Z greater than 10 by 4 C is on the left side of that Z.
right side.
Okay, right side.
So when we actually say it is 1 minus, we are talking about the area which is right side of C. So that is a probability. That is a probability that we are showing that it may not be a null hypothesis has to be is not satisfied. Is that correct?
Can you repeat it?
When we are actually saying 1 minus fz of some value, we're talking about the right side of the place where you have drawn this. Yeah, that corresponds to C. That line corresponds to C, and whatever is there on the right side
That
is what
line corresponds to root 10 C by 4. So our
correct.
Z should be greater than something like root 10 C by 4. Okay.
Yes. Yeah.
So this is the probability we are interested to find.
Yeah. So that is the probability that I'll be rejecting the null hypothesis, or T is going to be greater than C.
T greater than C. So we look for T greater than C.
Okay.
So this is actually we are computing the type 1 error.
Correct.
Okay. We are interested to find the type 1 error.
Right.
So we brought a relation between type 1 error and C. See this particular
yes.
C. So this type 1 error is a significance level we call. Okay.
Right.
That means how much we can relax our testing. So whether there can be a possibility of 5% error, can you allow 5% error of type 1 error or 10% error? This is in our hands. You can fix this alpha.
Correct.
Okay. By fixing this alpha, we correspondingly compute the value of C using this inverse and inverse Z tables and whatever we do. Finally, we can compute C.
Yes.
Okay. After you get C, so C may be somewhere. So this is root 10C. So C may be somewhere here.
Yeah.
This is C.
Yeah.
Okay. So if your T value falls above C, maybe in this region. Okay. If your T is something here, then we reject null.
Then we reject the null hypothesis.
Then we will reject the null. If your T falls inside this region, maybe the left side of C, in this region, okay, we will accept null. So if T is in here, we will accept null. If T is inside here, we will reject null. Okay. But before that, we have to find this particular C. So we don't know what is C, right?
Yeah.
So for that C only, we are doing all these things, probabilities and computing. See, these are all the computations. So ultimately, we will get one C value.
Sir?
Yeah.
In this example, say for example, if I take alpha equal to 0.05, right?
Okay, you take 0.05.
So my FG inverse will be FG inverse of 0.95, right?
0.95, yeah.
So I will go to that table and I will identify where 0.95 is there, right?
Yes, where inside the table, where is 0.95, you have to observe.
Yes, so can we go, sir, and complete this exercise?
Yeah, okay. So let's say alpha is 0.05. So 1 minus 0.05.
Yes.
So this will be something like 4 by root 10 into FG inverse of 0.95. So now we are interested. So now we should know at what value we will get the probability
0.95.
0.95. So you see in this table, so 0.9236929394.
1.65.
Yeah. 94 and there is 95053. So this is the best value we can choose for 0.95.
1.65.
So correspondingly it will be 1.65.
So my G value will be 1.65, right?
What is G value?
From G table I am calculating my G score.
So this particular value from the Z table is 1.65. Yeah.
Sir, can you move to that okay, please, sir. Sir, from that graph on that table, there was a normal distribution graph. We could see that there was a Z, and the left side was the Z.
Hmm.
Can we move to that table, sir?
Z table.
Uh,
Okay.
sir, move upward.
Upward.
Here only, here only.
Hmm.
Sir. I think you can write here also, sir. Sir, here we are given that like 10 by 4 C is greater than Z, right?
Z is greater than root 10.
10 Z is greater than root 10 by 10 by
Root
10
10,
C by
root 10
4.
by 4. Root 10 by
root 10 by
4.
4 into C.
C, yeah.
Then it will lie on the right side of Z.
Right side of that root 10. So our small z value is now root 10 by 4 into C. So the small z is root 10 by 4 into C.
So I think you can write here, sir.
I can't write.
From upside, you can click check on annotate. I think.
Acha, you want me to annotate? Use the annotate.
No, on that website only. I think you can write. There could be that any drop on and zoom option, sir.
Okay.
On the top corner, sir, you could see any zoom option. Not there, sir. Not there. Not like on the middle of your screen on the top. On the top. A zoom drop down it could be there.
Okay. Okay. There. Okay. Zoom drop down. In
Uh-huh.
that what?
Annotate.
I didn't have any annotate thing here. I have mute, start video, security, participants, new share, pause, remote control,
Okay, sir.
remote control. Yeah, that's it. And more inside, more record on this computer, record to the cloud, meeting info, hide audio settings, video settings.
Okay, sir. Can leave, sir. But sir, if Z is greater than that root by 4 into C, then Z lies on the right side of
right side of the that particular
sorry,
value. Correct.
Z lies on the left side, right? No, sir, because Z is greater than Z lies on the right side, right, sir?
Right side. Correct.
Okay.
So that is what we discussed, right?
Can you please go to the table, normal table?
See, this is the normal table.
I just want to ask a question here now. Let's pick a number 0.75. It
0.75.
inside the table somewhere, okay?
Okay, inside the table 0.75.
Okay. Now suppose I am getting a number in between these two things, 0.758 and 0.761. We need to interpolate that. How do we do that?
See, you can take the mean of it. So it's in between. So you wanted 0.75, right?
Yeah.
In order
suppose
to
let's take it 0.75, 0.759, something like that.
0.75.
Is it normally allowed? Is it normally allowed to take an average of these two consecutive?
Yeah. You can take the average of these two. See here only 0.75. You got you want FZ inverse of 0.75. You have to compute FZ inverse of 0.75.
Okay.
So it is in between 0.67 and 0.68. Correct?
Okay.
You can choose 0.67 or 0.68, but among these two, instead of these two, 0.675 gives you a better result.
Okay.
So that will be very nearer to what these two are.
Yeah. Suppose if they're asking the result by 3 decimals, so we can take an average and do that one. Is that right?
But we mostly, if we got 7.5 also, we actually compute this using 6.7 and 6.8, and we give the range, and we increase the range and we give the value. So
Okay,
you
sir.
don't worry about that. But if you want a better result, better computation, you can take the mean of it.
Perfect. Thank you.
Okay.
So completing that exercise, FG inverse of 0.95 is 1.65, right?
Yes, 1.65.
Sir,
the
is
value-
it-
So now can we complete that, sir? 1.65.
Sir, that 1.65 is F inverse 0.95 or FZ 0.95, sir?
FG inverse.
FG inverse
See,
0.95. FG inverse
FG
0.95.
FG of anything is actually the probability that Z is less than. This is the probability FG of this.
Right.
Okay.
Yes, sir,
Both
yes.
will not be
Yeah.
equal, no, sir?
So can we
Both will not be equal, sir.
Both will not be equal.
FZ inverse and
For
FZ
some Z
values.
it may equal. You can.
Okay.
For
can you
some Z.
so can you scroll up? So this one I thought it's very vital for the conversion from FZ to probability. In the previous screen, there's one value you have done. So can you scroll up the next page above? Page above, sir. Yes, sir. One second, sir. Yes. Conversion from FZ to probability. Yeah, I just wanted to make 1 minus FZ square root.
So from this we conclude that we don't need to find like alpha value anymore.
For
We don't need to find the alpha value anymore. Like it would be
given.
given.
So when we say FZ
So
of
you don't expect us to find alpha value as we
See.
were finding yesterday.
We do see. We expect you to find p value, not the alpha value. Okay, we will discuss that p value also now.
Sir, so here when you have FZ of some value, it is same as saying that we are actually computing probability of Z less than or equal to that value, right? Okay, thanks.
Okay. So that is, so these are all the computation we do in order to calculate. We are interested to find. So we know alpha. We are interested to find the critical value.
So now on solving it, we will get critical value.
So on solving this, let's say alpha is known and alpha is 0.05. We wanted our test to be at a significance level of 0.05. That means no more than 5% of error is allowed. So that is what this signifies.
Correct.
Okay. Now this particular C value we are going to compute at alpha is equal to 0.05. So if I substitute 0.05 inside this, I'm going to get this. By looking at the table, FG inverse of 0.95 is 1.65. So this value we have seen from the table. So just substitute that. We are going to get something like 4 times 1.65 divided by root 10. So anyone? So this value will be times 1.65. So this value is somewhere around 2. So if I compute 2.087, but if you see above, just above, we have given you that. So when alpha is 0.05, C value is 2.08 for this case. So our computation is correct. So whatever we did is correct. Now
2.08 is.
Yeah. So now the critical value. So now we got critical value. Value C we got, which is equal to 0. something like 87. So what it means? This means so to C value 2.08 somewhere around here. So let's say C is this. Now what this tells us is, what is our test? We are going to reject H0
P is greater than C.
if T is greater than C. So now we have the C value. So we no need to, we can replace that C value with 2.087. So ultimately, after getting the critical value, our final step is to find is to compute the test statistic.
Correct.
Test statistic T. In this case, it is X bar. So once you find X bar, suppose your X bar is in the right side of C. Suppose your X bar is somewhere. So this is only the value I am taking, 2.5 you got. So 2.5 is somewhere it will be here, which is in the rejection region. So above this we will reject. And below this we are going to accept. So that is what the test is. You are going to reject H0 if your test statistic value is 2.087. So the acceptance is T less than or equals to 2.087. So this is the region in which we accept H0, and this is the region in which we reject H0. If your test statistic is some 2.5, so for this green value we are going to reject H0. What if so your test statistic value is somewhere around 1.5? So that is 1.5 is somewhat here, or maybe very nearer to, so here, maybe this is 1.5. So as this is in the acceptance region, so what we got is our X bar is actually less than our C value. So X bar we got like 1.5, which is less than C value is 2.087. So what we are going to do, we are going to accept H. So this is what we do in Z test. This particular testing for means. So once you know the significance level, so this is what we are going to do. So we compute critical value C using the significance level alpha. Then what we do, we are going to compute the test statistic using the samples. So using the samples or observing the samples. So test statistic T. Then what we do, finally we compare both. Compare T and C, and using the test, we finalize whether to accept H0 or reject H0. So see here, compute critical value using the significance level, compute the test statistics using the samples, and using the test finalize whether to accept or reject. So these are the steps involved in this particular problem solving. Okay. Okay, clear?
Yes, sir.
So now let's see another way of solving this particular or testing for means. Another way of testing this hypothesis is to find p-values. So what is p-value? So p-value is, if you know, we know the samples, right? When we know the samples, we know the test statistic, and this particular test statistic will be equal to some static value. Let's say suppose it is equal to some t for one sampling. So if you look at one sampling, some n samples inside it, and whether it is mean or sum or anything, you compute the test statistic value and suppose that is equal to t. By considering this small t, the lowest significance level alpha for which this null is rejected, for this t is equals to t. So that means whatever the t we got, small t we got as the test statistic value, so that should be the critical value. So if this particular small t is equal to the critical value, then we compute alpha. So the lowest significance level value alpha is called as the p value.
Sir, then why it is called lowest? It is the highest, na? Say for example, if my alpha is 5%,
Hmm.
so it is 0.05, right?
Hmm.
So whenever my t becomes equal to c, right?
Hmm. Hmm.
So that will be the highest value will be 5. Why it is called the lowest significance?
It will be lowest only. I will show you.
Okay.
So what is a small t?
Small t is the value, test statistic value.
Value of t when it becomes equal to critical value.
No, small t is actually if you have seen the samples. So if it is Bernoulli, it will be like 1 0 1 1 0 1 0 0 0 1. So these are some samples of Bernoulli. Now, if your t is something like sample mean, so then what is your value of t? That will be like 1 plus 0 plus 1 plus 1 plus 0 plus 1 0, and there is one more divided by some 1 2 3 4 5 6 7 8 9 10. So there are 1 2 3 4 5. So it will be 0.5. This particular 0.5, the static value we refer to as t, small t. Okay. Capital T is a random variable, small t is a value. Understood?
Small t will be given.
Small t will not be given, but the samples will be given. You can compute the small t using the test statistic.
Okay.
Okay. So this particular 0.5 is what small t is in this particular case. So whatever we compute, so whatever we are computing here, so this is using the samples you compute the test statistic value, right? So that is called small t. So that is what we given. Suppose capital T is equals to some value small t, which we know. The small t we know. This is
Small
fixed
t
for
is
one.
simply we can say that result of test statistics.
Result of
Test statistics,
what is the
like
Saying
result
that
of
test statistic.
test statistics.
see result. We use this test statistic in order to perform the test. So so if you have to perform one test, so how are we performing that test? So when are we going to reject? When are we going to accept? What is the test actually being done? So that particular test, that comparison thing. So comparing only we will verify, right? In
Yes.
this hypothesis, we are going to compare things. So for comparing, we usually compare numerical values. Okay, taking in the numerical values, we compare. So for getting those numerical values into the test, we use this test statistic.
So we have to fix our significance value according to that small t, no sir?
Now in this particular p value, we are going to fix, we are going to find alpha, for which alpha this particular critical c is equals to small t.
2t. Okay.
So yeah, why it is lowest is because this. So let's suppose say this is the c, and the corresponding alpha is the probability of this. So this will be the alpha, because alpha is nothing but probability of reject h0 when h0 is true. So this is basically we are going to reject when it is greater than c. So this alpha is actually the area under this curve. Okay. And let's suppose say you have some t here. This is the t. And this is c. And there is, if you take some more c dash, one more c dash, which is another critical value, then your alpha dash will decrease or increase? This is alpha dash. Decrease. So this is alpha dash, and there is you consider one more thing, maybe some C double dash. So what will be the corresponding alpha double dash?
Again
Further
decrease.
decrease.
Further decrease. So now you tell me, will it be the lowest
Yes,
value
yes,
of alpha or the
lowest.
greatest value of alpha?
Lowest.
So for this T, there is some alpha star, correct? So if T is taken as the critical value, now C, C dash and C double dash, and now we are taking T. So for T corresponding to this particular T, there is some area, some alpha star. This particular alpha star is called the p-value. So this is called p-value. So p-value, you simply what you have to do is probability that t greater than c given h naught is true is there, right? So you simply replace c with small t, where you know the small t value. When you see the samples, you can actually compute the small t. So this is known now. Now if this is known, you can actually compute p-value. Okay, p-value is for alpha. Okay, so the p-value is actually the lowest significance level alpha, for which you are going to reject the null for this test statistic value. That is what p-value is. Okay, so your p-value will depend on the test statistic value. Correct?
In earlier cases, we were using T to compare the C value. T was only one, means we compared 1.65 with 2.08.
That is for alpha and C critical value.
No,
There is no T.
We calculated T, na sir. Test statistics.
Test statistic we calculated
and compared it with C.
Compared it with C, correct.
So if we are replacing it with C, then what is the point of T?
See, here we don't know alpha. We are trying to find the value of alpha. Okay. So here we are trying to, there you know alpha. So that is why you are computing critical value and you are comparing with your test statistic. And if you don't want to do that, so you are not interested to fix your alpha, and you know only the sample, right? You have seen only the samples, and you can only compute test statistic value. Other than that, you don't know anything about the distribution, correct?
But then alpha will have no significance.
Here, see here.
Whatever alpha, whatever be the means, I am not getting it. Means
okay.
T, capital T is a random variable or is it a constant?
See here random in this case, variable. Capital T is a random variable.
So we are. So we are taking many samplings of to capital to be a random variable. We have to have many samplings.
No, not that case. Instead of choosing one particular sample output value, we say sample 1. So where sample 1 can take any value. Okay. So see, capital T, we are saying it as, let's say we are saying it as like this. Before that, see what is this x1, x2, xn samples coming from normal 0, 1. I just say normal 0. So these are samples. Are x1, x2, xn are random variables or?
But that's the that will be the samples given to us.
Samples, that means you are saying this is not a random variable.
Means they are before us. They will be the result of our testing, na, sir, x1, x2, xn.
No. So see, this value you don't know, but you know this is sample 1.
Yes.
Okay.
But we will be calculating T based on the results of the test.
Results of the test. But before that only, we fix this test statistic. So we will, if
Okay.
you have some n samples
Okay,
with
okay,
you,
okay, okay.
I will compute the mean of that samples and I will take it as the test
Okay, okay.
statistic.
Okay, okay, okay.
So that is why
Got it, sir.
capital
Got
T
it.
is a random variable. So
Okay,
after
sir.
looking
Got
at
it.
the samples, it will be like small x1, small x2, small xn. Okay. So now
Okay,
this small t is x1 plus x2 plus xn divided by n.
okay.
Okay, sir.
Okay. So understand the
Okay, got it.
difference. Yeah.
Sir,
Hmm.
may I see why I had asked about lowest significance level?
Hmm.
What was the confusion? Say for example, my alpha is 0.05, right? 0.05.
Hmm.
My alpha is 0.05, right?
Hmm.
And if I get my p value 0.02, right? My
P value.
p comes 0.02.
Hmm.
I will reject my null hypothesis. Okay.
Hmm.
I get my p value as 0.03. I will still reject my null hypothesis, right?
Hmm. Hmm.
When I will get p equal to 0.05, I will still reject, but the moment my p value becomes greater than alpha, I don't reject my null hypothesis. Correct? That is the reason why I was confusion. I was saying that p, it is the maximum p value.
No, 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 no. That is wrong way
That
of
is, I was
interpreting.
taking that route to, understand.
No, no, that's one. Okay, so I will quickly summarize what we did till now. So we have did two methods where one method we are fixing significance level and we are picking. So this choice one, see in the choice one, what we do is we pick a significance level and next what we did, we computed the probability of type 1 error, and in that probability of computing type 1 error we have C. So we have some arbitrary constant C and we are trying to find that C. And usually we use 0.05 and 0.01 as the significance level point. So that is why if we fix that 0.05 or 0.01, then we find the critical value C, then we find the rejection region, and finally what we do is we actually reject H naught if your test statistic value is greater than C, or if we will accept H naught if your test statistic value is less than or equals to C. So that is what we do in the first choice thing. So where we have critical value and significance level is known. Okay, but if you don't want to use all these things and you feel like I know only this test statistic value, how can I fix significance level and how can I guarantee, I don't know what to choose as the significance level, then use this p value.
So can you repeat that? Choose one.
Choose
Like choose one.
choice one.
Choice one.
Choice one is like we pick the significance level first. That means we fix alpha first. So usually we use 0.05 or 0.01. Once you
Sir,
fix
in choice one to the T should be small t, not
t,
capital T. Small t should be greater than C, not.
so when it comes to the comparison, you compare with small t and small t greater than C, you reject H naught. See, these are all before. So before the computations, okay, that is why we use it as a random variables. Okay, before the computation, you don't know the samples, and before, why I say before is actually the setting we do before we take the samples.
Okay.
Okay, once you take out the samples, then your t becomes a static value. Matlab,
Okay.
it is a fixed constant. Now capital T will convert to a small t for that sampling. So comparison will happen between small t and small t and C. You are correct.
Okay.
Okay, yeah, but usually we write it as a random variable. So before these things, okay, yeah. So you fix alpha. Once you fix alpha, then you compute. So you find the value of find the critical value. See how you find it out using this alpha is equals to probability of type 1 error. You use this inside this you will get a constant C. So one equation, one variable, you find the value of C in terms of alpha. So you know alpha, and in terms of alpha you find the value of C. Once you have the value of C, then you compute test statistic value. By looking at the samples, you compute small t. So then compare small t with this critical value. If it is greater, you reject. If it is less, you accept. So that is what we do in this choice one. Okay. So if you are not interested to find this critical value, and if you are not interested to pick this significance level, or this alpha, you don't want to fix alpha. And in some cases, we don't know how much error we can tolerate. So in that cases, what we do is we use this p-value case. So whatever we do is, in this thing, we just report the p-value. P-value is actually probability that capital T is greater than this T, given null is true. So you simply replace small c with small t. Then you compute the probability of this particular random variable t going greater than t. How much chance is there for this random variable t can go above this small t? So that is what p-value is. So just you take the p-value. If the p-value is very, very low, maybe like 0.02 or 0.01 or 0.005, something like this. If you got p-values like this, we actually happen to reject H0. We simply reject H0 because p-value is very, very low. So that means the chance for this particular test statistic, the chance of going error, type 1 error, is very, very low. You understand this point? So that means this particular t is far away from the mean. So whatever the small t we are going to get is very, very, if your p-value is area under the curve. If your area under the curve is very, very less, that means this particular t is very far from what we are actually testing. So if it is that far, we actually happen to reject it. Okay.
Sir, both alpha and p is basically probability of making type 1 error, right?
Yes, yes.
Correct.
See, p-value is actually the lowest significance.
Correct. So both are probability of making type 1 error.
See, in this
Sir?
case, we find alpha. In this case, we find C. So in this case, we know alpha, we find C. In this case, we know C, you find alpha. What is C? The test statistic value is what the C is. So that is all. And yeah, something like this is actually a some war between this choice 1 and choice 2. So how low is low enough? Like how much low should I, like whether this is low enough, can I reject, or even I cannot reject, is what it depends on the applications and other information. Okay, so that is why some people might go with choice 1 and some will say choice 2 is better, like this. Okay.
Sir,
yeah,
didn't understand that second line of choice 2.
Second line of,
if p-value is low enough, choose to reject H0.
Yeah, we choose to reject H0 means we actually tend to reject H0. So if your p-value is low, like 0.02 or 0.01 or 0.005,
rejecting H0 would be accepting H8. Then you say otherwise.
That is a mistake, sir. Typographical error.
Okay.
Yes, that's a typographical error. Even in slide also it's a mistake.
Accept H0.
Yes, yes.
Okay. Thank you, sir.
Yes, it's a typo error in slide also.
Okay. Let me ask you, have you gone through 10.7 and 10.8 problems?
No, sir.
Yes, sir.
No?
Yes, yes.
Yes, no?
No, sir.
No?
No, sir. No, sir.
Yes, but
Okay.
don't remember, sir. Yes, but forgotten.
I can't forget 13, 14.
That counts as a no.
Yeah.
Yeah.
Okay. So do you guys need any break for some time?
Sir.
Yeah, for 5 minutes would be fine. 5 minutes would be fine.
10 or 15 minutes.
10-15 minutes I can't give.
15 minutes क्या करेगा यार? 5 minutes.
Maybe at most 5 minutes I can give, not more than that.
5 minutes.
5 minutes. 5 minutes.
Yes. Okay. Even I will have some water and I will be back.
Yes, sir. Yes,
Let's resume it.
Sir, मैं भी पानी पी लिया.
Okay. So we will resume at maybe 1917. Okay.
20 कर देते सर.
20. 20 is too long. Okay, let's make it 1919. Okay. Yeah.
Okay, sir.
1919 में कोई नहीं आएगा. Because 1919 is over.
Hello, sir. Are you back?
Yes, yes.
Sir, just a small request. Before you wrap up the session today, if you can kindly explain that bit about p-value where alpha, c dash, and c double dash. Before you wrap up today, sir, you don't need to do it now. I bit more clarity, require a bit more clarity.
This particular thing, is it?
Yeah.
Okay. Maybe at the end. So
Yeah,
when
absolutely.
everyone leaves, we will discuss some 2 or 3 minutes more. Okay.
Surely, sir. Thank you so much.
Okay. Is everyone back, or can everyone raise their hands? Whoever is back, can you raise their hands? 4, 5. 10. Aditya is not back yet.
Aditya has gone for 15 minutes break, sir. So we can start.
He will come after 15 minutes, sir.
Yes, so we can start, sir.
Anyway, we said 1919, right?
1919 will not
So
come
why
today,
is
sir.
1919 I gave?
That will not come today, sir.
Arre, 2119. No one questioned and no one.
I questioned immediately by that time I had left, sir.
Acha.
He understood the meaning, sir. So we didn't question.
Okay, okay. Okay. Okay, tab tak, those who are back, just read this question and try to solve it. So my screen is visible, right?
Yes, sir.
So just try to read this, and whatever we studied till now is what applies here also. The same thing, but with problems. Now we have specific values, and this is the computation we are going to do. And this computation we are going to do again and again and again till week 12 ends. But you might see different test cases, different tests, different test statistics, and different scenario. But ultimately, either one of it we will do. Either we fix alpha, compute critical value, then compare, or we simply compute p-value and we will reject or accept.
In case of this problem, can we fix the p-value, sir?
So we can compute the p-value also, but it is actually given, alpha is given to us.
This alpha is given, but
Okay. Now what conclusion would a z-test? So z-test is basically we do for when you know the significance level alpha, you compute critical values. That is what in 10.5 lecture is. So you compute the critical value, you compute the test statistic value, then compare those two by using the test. So test which we are going to define, and then reject or accept or whatever.
So
Okay.
calculating p-values do not involve, that doesn't mean we are doing a z-test. So the z-test is only when we are fixing
Yes.
alpha and finding out c. Is that
Correct. Okay. So how do we start this first?
Identify the test statistic.
So we are going to set up all the things what we know from the given question. So it is given that x follows normal mu 9, and there are some 16 IID samples of x. So that means x1, x2, and so on, xn, x16 also follows normal mu 9. Correct? This is the second line of it. And also it is given that the sample mean is 10.2. So what is actually given? We also gave you the sample mean, which is x1 to x16 divided by 16. Aditya, are you back?
Yes, sir.
Okay. Okay.
But I had my dinner.
बीच में
हाँ सर.
अभी
हाँ सर.
ओ लगता है सुपरमैन की तरह. Okay. So the sample mean is given to us, which is equals to 10.2. Now the question is, what conclusion would a z-test reach if the null hypothesis is mu is equals to 0.95? So we also gave you the null, which is 9.5. So this is all set up. We are going to set up before we compute the problem.
See.
And alternative is also against an alternative hypothesis, mu greater than 9.5. Okay, and at a significance level of alpha. So alpha is also given to us 0.05. Okay, this is the first question. And the second question is, what if the null hypothesis assumes 8.5?
Correct.
So that is the second question. So this is the first question. We will try to solve it. So what conclusion? Conclusion matlab whether you are going to reject H0 or whether you are going to accept H0. So in the last lecture, I have said one thing. So when you are going to fix your test, so what test should I follow? When am I going to reject H0? So reject H0 if X bar and there is C. So when am I going to reject? When it is
X bar is
greater
greater
or
than
less
C.
than?
Greater than C.
Correct. So again, I am repeating, if you are confusing with these things, whatever the alternative hypothesis ka sign is there, the same sign holds for the test, because if sample mean is greater than the critical value, what it tells is mu is actually greater than 9.5. It's not 9.5, it's actually greater than that. Your sample mean itself is, you are getting, which is greater than some critical value. So we are getting greater values, higher values. So mu is not 9.5, it is higher than that. So alternative will become true if you do this test. So it is between either it is greater or it is equal. So if it is greater, then equal to will not hold. So that means alternative should be true. So that is how you define your test. So this is what the test is now. So we are going to reject H0 if our X bar is greater than C. So what is C? We are going to compute using this alpha.
So what will happen if X bar is less than C?
We will accept H0. If it is less than C, mean, so you have observed one sample and uska mean is somewhere less than maybe 9. It is 9.4 or it is 9.3 or something.
Okay.
So what will you do? You say that, yeah, okay, as it is 9.3, mean may be equal to 9.5. It's not greater than 9.5. So you accept H0.
Okay.
So as this is test, then you can define the acceptance set also.
Okay.
So what will be the acceptance set now? Corresponding to this set?
Greater than 9.5.
X bar less than C.
Less than
Or equal to C.
Yes.
So it's just the complement of this test. So if
Yes.
you are going to reject H0 in this particular cases, when are you going to accept H0? For what values of X bar you are going to accept H0?
Less than
When it is
equal to
less
C.
than or equal to C. So now our first thing is to compute, find critical point, critical value, which is nothing but find C. So we are going to find C here by using this probability that we reject H0 where H0 is true. So rejecting H0 is X bar greater than C. H0 is true means null is true. So your mu is 9.5. So now when mu is 9.5, our X follows normal 9.5 comma 9. Correct? Just substitute mu. What will our X bar follow? This thing you have to tell me.
9.5.
Okay.
Sigma squared by n.
Sigma squared by L. So 9 by 16.
9 by 16.
9 by 16.
Correct. Now our X bar follows normal 9.5 mean and variance 9 by 16. So if this is this, how can I convert this X bar to standard normal?
X minus X bar.
You wait, Ganga Prasad, just wait. Anyone other than? So if X bar is normal 9.5 comma 9 by 16.
Yes, then
In
X
order,
bar minus 9.5.
yeah. divided by
9 by 16.
Square root,
square root.
under root.
So this is variance. So you have to divide it by standard deviation.
Oh, yeah.
So this will follow normal 0, 1. So that is what we are going to do. So x bar minus 9.5 divided by 3 by 4. So I have written it directly. 9 by 16 ka square root is 3 by 4. So greater than c minus 9.5 divided by 3 by 4. Okay. So if you simplify this, we are going to get, this is standard normal. So this is what we know. So this is z greater than 4 times c minus 9.5 divided by 3. Or else let's keep it 3 by 4. So now what is this? This one will be equal to 1 minus fz of c minus 9.5 divided by 3.4. Correct? So I have skipped 2 steps here in between. That's it. But ultimately you are going to reach here. Correct or wrong?
Yes, sir.
Yes, sir.
Yes. Now I know
Yes.
alpha value. What is the alpha value given? 0.05.
0.05.
Yeah. So if it is 0.05, so you just simplify this. This will be like fz of c minus 9.5 divided by 3 by 4 will be equals to 0.95.
95.
So from here I can get c value as, so I'm writing it directly, 9.5 plus 3 by 4 into fg inverse of 0.95. Is this correct? So you just take fg inverse, you just bring 3 by 4 to the right hand side, then bring 9.5 also to the right hand side. So it will become, c will be equal to 9.5 times, sorry, 9.5 plus 3 by 4 into fg inverse of 0.95. Correct? So from this step, this will follow. Agree?
Yes, sir.
Sir, can you repeat that last step?
Okay.
The last step. Not that, after that.
This one only, right?
That one.
This one.
Yeah.
Okay. That we are going to get it from here on. So if this is this is c minus 9.5 divided by 3 by 4 is equals to fg inverse of 0.95. Just you're taking the inverse of it. Correct? This is correct?
Yes, sir. Yes, sir.
From here, what I will get is c minus 9.5 will be equals to 3 by 4 times fg inverse of 0.95. Is this correct? So 3 by 4 bringing to the right hand side. Okay. So it's in the denominator. So you just multiply 3 by 4 on both sides. You will get this. So this is c minus 9.5, which is equals to 3 by 4 times fg inverse of 0.95. So this will imply me, if you bring 9.5 also to the right hand side, you will get this. C will be equal to 9.5 plus 3 by 4 into fg inverse of 0.95. We just saw what is fg inverse of 0.95. What is this value? So using standard table, above also we just got the value.
1.65.
Yes. So fg inverse of 0.95 is 1.65. So we can use that. So this is 1.65. So the critical value C will be 9.5 plus 3 by 4 into 1.65. So what is this value will be?
10.7375. 10.7375.
10.7375. कितना आएगा क्या?
मैं तो इसी को फिर से चेक कर लेता हूँ.
Sir, उतना ही आएगा.
इतना बड़ा नहीं आएगा. See, the computation is very small. So divided by 4, you will get more, not more than 2 values.
Okay, let me check again, sir. Let me check again. 1.65 into 3.
It's correct,
नहीं
sir.
sir, सही है sir.
10.73.
10.7375.
10.74.
Okay,
That's what the
10.7.
round up is 10.74. Yes.
Okay, 10 point. Okay, less than 10.7375, right?
Yes.
Okay.
Yes.
So now we got the critical value. Also, we have the test statistic value, which is sample mean. Okay.
10.2.
So in this testing for mean, we are going to test for sample mean only. Test statistic is the sample mean. So what is the test statistic value given? 10.2. So now you see we have 10.2. So comparison. So we have test statistic value x bar as 10.2. And we have other side, we have critical value which we got 10.7375. So if you compare which one is greater, which is the greatest one?
Critical value.
Critical value or the C value? This is the value. 10.7375 is greater.
So we accept.
So our sign is x bar is actually less than C. So is it falling in our acceptance set?
Yes.
So therefore what we do?
Accept. We will accept.
We will accept it.
Null hypothesis.
Okay. Yeah. So the second question says, you instead of 9.5, you just take 8.5. So what happens now? The same approach. The only change happens here. So instead of 9.5, this will be 8.5. This will be 8.5. If it is 8.5, this is 8.5. Can I mute everyone? Okay, this is 8.5. This will be 8.5. Wherever 9.5 is there, that will just simply be 8.5. So this will be 8.5. This will be 8.5. So the new for the step 2, C value will be
9.7375.
8.5 plus whatever 3 by 4
Yes,
times
yes.
1.65. So you can compute that. You can do that. You do that.
9.737. 9.7375, sir.
So this is 9.7375.
75. Yes.
Okay. Now we have C value as 9.7375 in the second case. Okay. So this is the case we are looking at. So X bar is 10.2 and C is 9.7375. So which one is greater? Greater. Which one is the greatest value?
This X bar.
X bar is greatest.
We will reject.
Yeah, when X bar is greater than C, what are we going to do?
We will reject null hypothesis and accept.
So we are going to reject
alternative hypothesis.
Null hypothesis and we are going to accept. This is the conclusion we draw. So the conclusion is, this is the conclusion we draw. So final conclusion is, conclusion for first part is actually Z test at significance level (0.05). We accept H0. So we accept H0. And the second conclusion is Z test at significance level 0.05. We reject H0. Okay, so these are the conclusions we draw from this problem. This is how you solve the problem. Okay, understood the easy one? Let's go to the
Yes,
slightly
question.
difficult one.
I have a slightly connected question. If you can just scroll back a little. See, there are times when you do this or when you do CIGT, all kinds of things. See, there are times when you take the variance of X. There are times when you take the variance of T of Y, let's say, where you add up 10 samples, right? X1 plus X2, right? So when do you do what? Like, for example, if it was, anything like 10 samples of something, and you could add, or you could take a normal distribution at something where you add those variables, or you could take it for the individual random sample, right? So IID sample. When do you take? Eventually, the answer will be the same, because in one case it will be sigma by n root n. In another case, it will be sigma into root n. Eventually, it will kind of come to the same thing. But when do you do what? Like, I am not very clear with that at times.
See, okay, if you are that confused about that thing, you take it as different random variable. Consider it as a random variable. Okay. So
Correct.
let's
Like, for
suppose.
example, suppose when do I do let's say there is a y which is x1 plus x2 plus x3. In some situations, maybe we have to add up. In some situations, we don't have to add up. Right?
You take sample mean at some places. You take just add up, and you don't add up. These are the cases, maybe possible cases which we dealt
Correct.
till now. Okay.
Correct.
Yeah.
So when do you add up and when do you not add up? That's where I get confused.
See, that depends on the problem.
I can like, for the added up variable, that's also a random variable. Let's say y. There is a certain normal distribution. For the individual samples or the sample mean, there is a certain sample distribution, right? So, I mean, I can use either of them, but when do you actually look at? Is there a specific case when you look at one of them versus the other? That I'm not very clear about.
Yeah. See, whenever it depends on the problem statement you have in front of you.
Correct. So can you just give an example of, may not be now, towards the end also, just an example of when you cannot use the sample mean, but you have to use the whatever, the added up random variable.
See, I will, in the examples itself we will get, I guess, in the problems while you solve, we will get to know when to add up. So what variable we should take as the test statistic. So that will give you clarity, I guess. Some clarity. If not, we will discuss at the end. Okay.
Sure.
Okay. So let's solve this second problem. So here it says, suppose an app is designed to make an accurate identification of faces in photographs more than 90% of the time in the long run. So if it is Aadhaar card, it fails like very drastically, right? So how many of your Aadhaar card exactly matches with your face?
No, sir.
No response.
Mine, in my Aadhaar card, my finger also doesn't match.
So here there is an app, it seems. So that app is designed to make an accurate identification of faces.
Actually, there is just a side, I'll take 10 seconds for entertainment. There are about very small percentage of the population who don't have any fingerprints. That's a huge problem everywhere, from passports to Aadhaar to everywhere. There is a small percentage of population who have no fingerprints at all. That's a fact I didn't know for many years.
Oh.
What?
Yeah.
What?
There is a small percentage of population who do not have fingerprints. So if they go for any kind of verification anywhere, whether it's at passport lines or any of these countries, you just put your hand. In Singapore, you just walk in after you give your thumb impression, right? So it doesn't work.
Interesting.
No, I have fingerprints.
Yeah, I'm saying yes, there is a small percentage of population who do not have fingerprints.
जिनके हाथ नहीं होंगे या फिर कुछ ऐसा प्रॉब्लम
it's a genetic defect or whatever, genetic reality.
For that, they are risk.
Anyway, sorry, back to you, Shrikant.
Okay. Thanks. It helps actually. So अभी भी बहुत लोग they are tired of listening to me. So this will help them to, अच्छा कोई और बात कर रहा है.
नहीं सर, ऐसा कोई बात नहीं, आपसे कोई tired नहीं हो सकता है.
Okay. Let us solve this. Let us try to understand each statement by statement. That will give you more clarity. So there is an app designed to make an accurate identification of faces in the photographs more than 90% of the time in the long run. So that means that app wants those who have created the app, he is desiring to create such that when I use this app and it runs for long run matlab, if more people are using it, then the 90% of the time it should accurately identify the faces. So for that thing, what he has actually taken is, he has taken a random samples of 500 photos, and what happened is the app makes the correct identification of 462 times. So this is given. So what is given? So the desire is to get more than 90% of accuracy. And what is the second statement said? So they have taken some random samples of 500, it seems. So let's
So
say
it means that the level of significance is 10%.
no, not the level of significance is 10%. It's actually the probability that identifying the face. Okay, correct and wrong. So here we have two chances. So once the person or once the photo is scanned using that app, either it can guess correctly or wrongly. Correct? And the correct percentage should be greater than 90%. Okay. So alpha is only the type 1 error. There can be type 2 error also. And collectively it should be 10%. Not 10%, it won't match actually. But it doesn't involve this 90% with significance level. That is what I wanted to say. So this is actually the probability of getting success. So probability of success should be greater than 0.9. Okay. So probability of success should be greater than 0.9. So that is what his desire is. For that to test a random sample of 500 such photos, the app makes the correct identification of this. What does a G test say about a null hypothesis that the app is only 90% accurate compared to an alternate hypothesis that the app is more than 90% accurate? So what is null and what is alternate here?
Null is 90%.
More than 90% is type
Ah.
null
So
and
more than 90% is so
alternate.
alternate. So more than 90%. So let's say success rate. Greater than 90% and success rate equal to 90% is what the null is. So when you look into or convert it into the statistics terms, it's actually we treat it like a probability of success. So let's say P is the probability of success. P is the probability of success. So the alternative will be P is equals to 0.9 with tested with alternative. So sorry, null will be P is equals to 0.9 and alternative will be P greater than 0.9. Okay. Yes. So we have this. And what else we need? We also had this 500 samples coming from the distribution IIDX. And X is Bernoulli. We know that thing also. Correct? So if I randomly choose one photo, either it says it identifies the photo or doesn't identify. So I will take one if it identifies correctly, and 0 wrong identification. So X is actually taking one photo. So X is randomly take one photo. Like this we have taken X1, X2, X3 like that 500 such photos, and all the 500 photos will follow the same thing, will follow this distribution only, which is Bernoulli. And we don't know this probability of success. So that is what we are going to test. So whether the probability of success is 0.9 or it is greater than 0.9. So this is unknown random variable P, which we are going to test it on. So now we have this, and we also have one more thing here. Can you identify what we have more? From the data we have.
alpha is equal to 0.
Sample success rate.
Yeah, sample success rate can be taken as
0.924 and else alpha is given.
Yeah. So we know this thing. So which is actually the number of probability of this 500 such photos, or proportion of success rate. We have the proportion of success rate, which is actually, you can simply see it as it will be actually X bar. Because you see, if it is correctly identified, X1 will take 1. If it is wrong, it is 0. So X1 plus X2 plus and so on, X500 is actually the number of correct identifications. Correct? So either
Yes, sir.
X1, X2 to X500, all these 500 values will be either 1 or 0, depending upon whether it is correct or wrong. And we know that there are 462 correct identifications. That means there will be 462 ones in the numerator and other 38 are zeros. So this will be 468 divided by 500. We have this. Now what is the test? So how do we define our test now? So when am I going to reject null? If
X0 is less
so
than
there is
C.
X bar and there is C.
X bar is less than C.
Less than C.
We reject X bar is greater than C.
Greater than C. Okay, Nikhil says greater than C. How many of you are supporting to Nikhil? Okay, 3
Yes,
people,
X bar is
4
greater
people.
than C. Sir, how did we get X bar 468 divided by 500?
That is 468 by 500.
The 462.
4, okay, sorry,
0.924.
462.
Oh, okay.
So it will be lower, less than C. Reject.
Okay, is there be
Less than C.
why? I just simply said that is why, don't confuse. Whatever the alternative sign is there, just put that sign. Okay? Nothing to confuse. I also explained it. You can just go back and see that explanation just before some half an hour, I guess, in the above example. Why it will be greater than 1. But blindly, if you want to follow, whatever the sign is there for alternative, that sign will follow for the test. So we are going to reject H0 if this particular sample mean is greater than C. So how to get this sample mean? See, this is Bernoulli with 500 samples. Okay. Now, if this is Bernoulli P, what will my X bar follow?
MP.
X follows Bernoulli P. What will X bar follow? Or okay, let's say there is Y, which is sum of the random variables.
500p.
So what will this follow?
NP, 500 into P.
Yeah, this follows binomial 500p. Correct? So this will follow binomial 500p. And if this follows binomial 500p, if y by 500 follows,
Y by 500 follows binomial only.
Binomial only.
Sorry. Yeah.
But what are the parameters?
P.
No, P by 500. 1 comma P by 500.
1 comma P.
1 comma P.
Sorry, no.
It's P. That's it.
Okay. So tell me one thing. So I have a random variable y which follows some distribution. So simple distribution. I will take Bernoulli. Not Bernoulli.
No, Y by 500 should follow 500 P by 500. Correct?
500 P by 500. Correct. So why it is correct is when y follows some distribution x with mean mu and sigma square, let's say. So what will y by some n follow? So you just compute the expected value of y by n. What it will be?
Mu by n.
So 1
Yeah.
by
N expected value of y.
y. So which is mu by n. And what will be the variance of y by n?
Sigma
1
square
by
by
n square
n.
variance of y.
Sigma square by n. No, sigma square by n square.
Yeah, sigma square by n square. Now tell me, if y follows binomial 500 comma p, and what is the expected value of this y?
500p.
500p. What is the variance of y?
And
500 into
p
p
into
into 1 minus p.
500
Correct.
1 minus. Yeah.
Now y by 500 will follow which distribution?
500
500p.
p by 500.
Expected value of y will be y by 500 will be
500 will come out. 500 will come out.
500.
So it will be like p.
Yes.
P
And
into
what will be the
minus
variance of y?
p into 1 minus p.
P into 1 minus P divided by
Sorry,
500.
variance of y by 500.
Yes.
So this will be like sigma square by 500 square. So that will be like p into 1 minus p by 500.
Yes.
Yes.
Okay. So this expected value is this, and this variance is this. Okay. If this is the expected value and variance is this, so how to get n now? This is n comma p, right? How to get this n? So, okay, though we don't worry about that n p. You can compute backwards, but right now
So
we doesn't require.
y by 500 will be 500 by 500p, na?
1 comma p.
No.
So y by 500 will be
No. Expected value will be 500 into comma p by 500.
500.
P will be the same.
Yeah, 500 comma, correct. So 500 comma p by 500. So that is what you will get. So the expected value will be p, and the variance will be p times 1 by p by 500.
So
Okay.
P is the probability, na sir.
Yeah, p is the probability of success. Okay. Now instead of taking it binomial, so there are 500 samples. Okay. What we do is we normalize it to normal. We normalize it. So what we say is this particular y by 500, which is x bar. So we just came from x bar. Okay. So x bar is nothing but x1 plus x2 plus x500 by 500. So y by 500 is nothing but x bar. So what we simply do is we normalize it. So we approximate it to normal with mean mu and sigma square, variance sigma square. What is the mean? P.
4 point.
What is the sigma square?
minus 2.
Correct. So you can use this or this. So this is the approximation we do. So you can compute using binomial, but it takes ages to compute. Okay, that is why if n value is greater than 30, we approximate it to normal by computing the expected value and variance of the random variable. We take mean as the first parameter for the normal and variance is the second parameter. So therefore our x bar is
So variance
normal.
of the sample, right? The variance of the sample mean, right?
Yeah, variance of the sample mean. So variance of the sample mean, and so that is what. See this
Okay,
particular
got it.
x bar.
Just clarified. Got it.
So now this follows this. So again the standardization, standard normal, converting it into standard normal. Correct?
Yes.
So the same thing, x bar minus expectation of x bar, which is p, divided by root over variance of x bar, which is this, will follow standard normal 0, 1. So till here we are okay. So now the actual computation part starts. So we are interested to find the value of C. So probability that we reject H naught given H naught is true. So what is this? Rejecting H naught. When are we going to reject H naught? When x bar is greater than C. So x bar greater than C. H naught is true means probability is 0.9. So from here, what are we going to get? So P. So you see, we have to do this, x bar minus P divided by root over P times 1 minus P by 500. But here we have given that P is the 0.9. So what we do is x bar minus 0.9 divided by 0.9 into 1 minus 0.9 divided by 500, greater than C minus 0.9 divided by 500. So this is the probability we are going to compute. And alpha significance level, we have taken it as 0.05. So in the question it is given, it is 0.05. So now this is standard normal. So you just see, observe, what are, we are doing the same steps. So this is Z. So this is probability that Z greater than C minus 0.9 divided by, this is something like 0.9 times 0.1 divided by 500. Correct? So anything new we are doing in the computation part, at least in the computation part?
No, sir.
No, right? So all the steps are same. So this is like 9 by 5 lakhs. So this is 0.05. If I, so 1 minus fz of what we can say, we can C minus 0.9 divided by 3 divided by 100 root 5, right? 0.05. So now from here I can get C value as, I am writing it direct, so just observe. So I can write it as 0.9 plus 3 by 100 root 5 into Fg inverse of 0.95. So you bring this to the left hand side, you bring 0.05 to the right hand side, it will become 0.95. Then Fg to the right hand side, so it will become inverse. So denominator you are going to multiply, and then you bring 0.9 also. So the direct step I have taken, that's it. So you simplify this, you will get this. And again we know the value of this, which is 1.65. So just substitute, get the value of C, critical value. So what will be the value? Something like 3.1.65 divided by 100 root 0.9.
10 root 5.
Hmm?
Sir, it is 10 root 5.
Is it 10 root 5? This is 5 lakhs, right? 10,000 ka square root is 100, right?
So 0.922.
0.922.
30,000.
3,000.
50,000.
Is this 50,000? There will be 2 more zeros. 2 more zeros will be added into this, and it will become 50,000. Yeah. So it is 50,000. Yeah, it's not 5 lakh. It's 50,000. Okay. So ultimately, when you compute, say someone said 0.922, just verify. But I think it's correct only. It won't go beyond 0.93. So C value is 0.922 we got. Now just the comparison. So we have X bar with us, we have C with us. X bar we computed it. It is 4, what is it? 462 by 500. What is 462 by 500 equals to?
Point nine
0.924.
To 4. Yeah. This is 0.922. So which one is greater?
9 to 4.
9 to 4.
X bar
Are we going to reject H naught or accept H naught?
Reject.
index.
So you see the test. The test says if it is greater than C, you reject. So it is greater than C. See, from here, the computation from here to below, everything is same. Whatever we did for the
Sir,
first problem
from
is same
here
for the second.
to above, can you explain once again?
This one.
Yes, sir.
This is actually the standardization.
So standardization is this much only, na?
Like, yeah, see, we are going to convert this, whatever the test statistic we have, to the standard normal. Okay. So what are the steps to do? You have the test statistic value, test statistic random variable. So you compute the expectation of test statistic, you compute the variance of test statistic, and what you do, test statistic minus expectation of test statistic divided by root over variance of test statistic will follow normal 0 1. So that is what we do. So our, in this particular case, it happened to be X bar. Okay, so we are trying to find the expectation of X bar and variance of X bar, and here also T will be replaced by X bar, and everything will be X bar. So you know X bar, expectation of X bar, you can compute expectation of X bar is this. So Y by 500 is nothing but X bar, because Y is X1 plus X2 plus and so on X 500. So this X bar is that summation divided by 500. So this X bar, you compute the expectation of X bar, you compute the variance of X bar. So these are the computations we did. So what we finally did, we did X bar minus, this is expectation of X bar divided by root over variance of X bar. That is standard normal 0. Why are we doing this? Why are we doing this? Because professor said we have to do. Is that what?
Okay.
Why are we actually converting everything to standard normal?
We have data for that.
Yes. So the probabilities, we have a standard table. So if you can convert, then we can compute the probabilities using the standard table, standard normal table. So for that, we are going to convert it into standard normal, and then we are going to compute the probabilities. See, here we are dealing with probabilities. So for this, we actually convert whatever the distribution is, we are going to convert, we are going to standardize it, and then we compute the values, and then we compare. Okay. Okay. So from here on, let's deal with the starting point, and the rest computation part is simple. Okay, I will do this problem, and maybe tomorrow is also a session, right? Open session. So the 11.8 examples, maybe we can discuss on that tomorrow. Okay. So I will give you this. We will try to get the setup, and we will try to normalize it and everything. So it is given that suppose X comes from normal mu 36, and there are 25 samples. X25, which follows IID X. And what other thing we have? We also have the sample mean with us. So X bar is there with us. Okay. And what conclusion would the z-test reach if the null hypothesis is mu is equals to 4 and alternative is mu not equals to 4. Okay, so it is also given at a significance level alpha is equals to 0.05. What if the null hypothesis? That is the second case, but this is the first question. So what is the test now? So if it is greater, we have kept it like x bar greater than c, we are going to reject. What if it is not equal to case? When are we going to reject null?
Mod of x bar minus c.
So when we are going to reject null is if this particular x bar statistic value minus that mean mu is greater than some c. So that means the region will be like this. So let's say this is mu. So if your x bar, whatever the x bar you are going to get, if it is in this region and in this region, we are going to reject null. And the region, if our x bar falls inside this region within C, the left side and the right side, within the C distance from mu, we are going to accept correct. So is this what the region that represents this? So we are going to reject h naught if the difference between mean and mu is greater than c. So when will it be greater than c? If your mean is somewhere in this or in this, the difference will be greater than c. Modulus difference will be greater than c. So the difference between mean and mu should be less than c. So that is the acceptance region. Acceptance set A will be x bar minus mu should be less than. So now we got everything we want. The setup was made. So the only part left is the computation. Okay. So what is rejection h naught means? Given mu is equals to some 4. So this is the probability.
So we don't have to normalize in this case.
We have to. So what is x bar?
X bar is
So
the mean.
x follows normal mu 36. So x bar will follow normal mu 36 by 25.
Yeah.
So if it is mu 36 by 25, alpha x bar minus mu by root over 36 by 25 follows normal 0 1. Yeah, this one also we should do. So after this, now we are ready. So we have to compute this. Okay. Will you able to compute this thing? So this is actually probability that mod x bar minus 4 greater than c. This is when I remove x bar, or you no need to remove x bar also. You already have x bar minus 4 with you. You see here we need x bar minus mu. So x bar minus 4 by root over 36. So you can actually divide root over 36 by 25 greater than c by root over 36 by 25. So this is actually mod z you are going to get. Mod z greater than some. maybe 5c by 6. So this is just the computation. Okay. Yes. So this is what we do. This is how we solve problems related to this hypothesis testings. Okay, these are all we have tested for mean. Testing for mean.
Can you move
Okay.
above, sir? Scroll upward.
Okay.
Okay.
So there are some very good examples in 11.8 lecture also, where in that lecture also we are actually testing the means. Okay, we had not started testing for variances, or we had not started the comparing to means and comparing to variances. That we will see in week 12. So as of now, week 11, we only test for mean, testing for mean. Okay, so every problem will follow whatever we discussed. Everything will follow the same thing, same approach. Okay.
Okay, sir. So our
Yeah.
test statistics till week 11 will be mean.
Yeah, week 11 last lecture also we will only test for mean. Testing will happen only for means.
Testing for mean.
Okay.
Okay.
And follow the same approach which we followed.
One question.
Okay, sir. Can you scroll down, sir?
Yeah, one question.
See, when there is a when p-value, if it's one-tailed, it's easy to determine. But if it's two-tailed, it's not that easy to determine. And I think you have to take the lowest of the two, or whatever, the minimum of the two, and then.
No. If it is two-tailed, it will be symmetric.
Yeah, but on one side it could be a different value, on another side it could be a different value. There was one problem I saw.
Can we take this thing only? Is this the thing, or? Yeah.
One problem in AQs I saw, I can't recall which one, which was.
Yeah, I understand the point. I understand the thing which you are referring. So sometimes the rejection region will be like this.
So just one query, sir. So this video that we have here, YouTube link for this session, that will be there at least till the term and exam, right?
Yeah.
Okay. Thank you.
So this is what, right?
Yeah, or the mean is not zero, so numerically you get different values.
Different values, correct.
Which one? Let me just pull out my AQs.
Yeah. So yeah, apart from that, whatever I wanted to discuss, I am done. So I thought of dealing one more problem for week 11, but sorry, week 11.8, but it's not possible now. So maybe we can discuss tomorrow. Maybe I'll ask Nikita. Nikita will be taking the session, so I will ask Nikita to take a few 11.8 lecture problems if you have.
Can't you
so just
take, sir?
see, for me tomorrow I can't. It's not possible for me. I'm traveling. Okay.
Please come for week 12,
Then
sir.
postpone. Okay, sir. Then postpone session from tomorrow to day after tomorrow.
What, man? See, even they teach well. Don't be like that.
Sir, please come for week 12, sir.
See, week 12 also I will take one session.
Yeah, like this only, sir. The way you have covered week 11, sir.
इतना lectures. I
अरे
don't
week
think
12
इतना
नहीं,
lecture.
2 lecture में आप 2 में कर दो
नहीं,
सर,
नहीं,
2 में कर दो आप।
एक
बहुत
या
सारा
दो
उसमें भी है
सन
ना,
आप ले लीजिए।
वेरिएंस है उसमें, बहुत कुछ है सर, वेरिएंस है, सब कुछ है, काई स्क्वायर है, क्या क्या है उसमें।
हाँ, but we will deal with
हेलो
Lost connection.
सर लॉस्ट कनेक्शन। आज ऐसा नहीं
भगा
हुआ
दिए
था।
क्या सर को?
हेलो,
आज ऐसा नहीं हुआ था।
अच्छा आई एम ऑडिबल सर।
ऐसा कैसे हो सकता है कि आज ऐसा नहीं होगा?
2 घंटे हो गए हैं, राइट?
ऐसा हो नहीं सकता कि सर मीटिंग से बाहर ना हो।
हमारे फ्रेंड सौरभ ने तो नहीं किया फिर से?
नहीं भाई, आज मेरे हाथ में कंट्रोल नहीं है।
कंट्रोल नहीं है, कंट्रोल रखा करो।
मुखिया के इलेक्शन में खड़ा हो रहा है, उसके बाद कंट्रोल हो जाएगा सौरभ जी के हाथ में।
अच्छा, तुम वोट दोगे ना?
हाँ, आपको भी लाया जाएगा वोट देने के लिए।
अच्छा, बिल्कुल आ जाएंगे। कहाँ पर आना है बता देना, किराया दे देना।
समोसा भी खिलाएंगे आपको, किराए का बात मत कीजिए।
Hello.
Yes,
Yes,
sir.
sir. Welcome back.
Okay. So
No, sir. I was saying not so many lectures, sir, but at least couple of lectures because so many topics are there, like variance and then chi-square. So many topics are there.
अच्छा, उस टाइम पे ही मैंने चले गए.
Yeah, उस time पे ही
Talking
connects.
a lot in that time only. So anyway, I'm going to take the activity session of week 12. So even
Sir,
though
open session, please take the open session, sir.
open session.
In open session,
sir.
you discuss concepts, sir. So that is.
Sir, the way you explain the things is.
Then what
सर
will you?
जो भी सेशन लोगे उसमें कॉन्सेप्ट बता दो बस.
That is what, right?
Yes.
Whatever the first session is there, we will discuss the concept so that in the
No,
next
sir.
session you will get a chance to ask the doubts or
Yes,
the
yes,
problem.
yes. Correct. Yes, fair enough, sir. Fair enough.
अगर पहला सेशन में क्या करोगे, अगर सेकंड सेशन में हम कॉन्सेप्ट डिस्कस कर रहे
नहीं, fair enough, sir. You come in then you come in first session, sir, right?
हैं.
So you are coming in the first session.
So as per schedule, I'm going to take activity session of week 12. Okay.
Let me check the calendar, sir, when it is.
Even if it goes for more than 1 hour, like 2 hours के बाद में भी गया तो I will try to finish within.
Yes,
I will
sir.
try to finish within one session. If not, then we will schedule like this another session. Okay?
So first session Saturday को add हुए sir. First session Saturday को add हुए sir.
First session
is on Saturday from 8 o'clock, 8 p.m. onwards. So hope you are coming
it's
on
on
that.
Tuesday, na?
No. Week 12 we start from Saturday, no? Oh, sorry, Tuesday. Okay. Yeah, Saturday is solve with us. Solve with us for week 11. Sorry, Saturday is solve with us for week 11.
So you are taking Tuesday session, sir?
Tuesday. If not Tuesday, I will take Thursday. इन दोनों में एक.
Tuesday नहीं होगा तो
Thursday.
तो Wednesday भी खाली है ना सर. Next Wednesday तो कोई assignment का भी load नहीं रहेगा.
Let's see. So if I didn't take Tuesday, I will take Thursday. And Thursday, if not completed, then I will take Friday. Friday भी खाली है ना?
हाँ सर. और आपका revision session वाला slot book है ना सर?
मेरा revision session वाला slot. Yeah. I'm going to take the last revision session.
Last is on 5th, sir. Last is on 5th.
Yeah, descriptive statistics part. मतलब week 7 से जो भी है to week 12.
हाँ, but sir एक दिन में कैसे होगा इतना सर?
weightage mail, sir.
एक सेशन में हो जाएगा.
सर वेटेज का मेल भी आया था सर.
वेटेज का मेल आ गया.
हाँ सर.
Okay, then we will more focus on end term only. So हो जाएगा.
8 to 12 है सर.
सर ने बोला हो जाएगा तो डेफिनेटली हो जाएगा.
हाँ
यार 5 तारीख को करके रिस्क.
सर एक ऑफ द टॉपिक चीज पूछे.
ऑफ द टॉपिक मतलब एक मिनट ठहरो. Let me stop the recording.
Sir, I wanted to ask one small thing, sir. Actually, on Sunday there is a proctor exam for Python people, sir. So, can you send it to Monday kind of thing? These Sunday submissions, whatever. Is it possible?
Sunday क्या है? Sunday what are the
week 11
अच्छा, week 11 deadline is on Sunday, is it?
Yeah, yes.
अच्छा, there is a OPP exam.
Same day, sir.
Oh.
OPP
Monday will be good, sir. Monday will be good actually.
Okay, I will ask the team.
Yeah, if it is possible.
Yeah.
Last time also I asked Mayur sir, but he said in the same lines. I don't know whether it is possible or not. I'm just asking on behalf of the other.
Okay. Let me ask this. See, your point is valid. Okay, I agree.
Thanks, sir.
And let me put this forward and let's.
Yes, sir. If it is possible. Thanks, sir.
Okay. Yeah. And ठीक है. और क्या है? That's it.
हाँ सर. सर ये थोड़ा सा ऑफ टॉपिक है सर. सर सर आप भी लिनक्स यूज कर रहे हैं सर, वो मेरा ब्राइटनेस का बटन काम नहीं कर रहा है सर, वो कैसे होगा सर?
ब्राइटनेस, अच्छा you are also
सॉरी
using
सर।
a Linux.
हाँ सर।
ब्राइटनेस का बटन नहीं काम कर रहा है।
नहीं सर, वो स्लाइडर से बढ़ाना पड़ रहा है सर।
स्लाइडर से मतलब?
वो साइड में ऊपर से
हाँ साइड में ऊपर से करना पड़ेगा। व्हाट डू यू वांट देन? दैट इज द
सर वो
अदर।
हाँ, वो बटन होता है ना ब्राइटनेस का,
हाँ
वो काम नहीं कर रहा है सर।
ओके।
कीबोर्ड का बटन।
हाँ कीबोर्ड में ब्राइटनेस का होता है ना, वो वाला काम नहीं कर रहा है सर।
काम नहीं कर रहा है कि यू डोंट नो व्हिच बटन इज दैट?
नो नो सर,
नहीं
आई
वो
नो
तो
सर।
सिंबल बना हुआ है 2 और 3 के ऊपर वाला।
ओके सो यू नो द बटन राइट?
यस सर।
काम नहीं कर रहा है, सो व्हाट कैन
लिनक्स
सर
में
विंडोज में काम करता था सर, लिनक्स में नहीं कर रहा है सर।
ओह
Thank you everyone. Thank you Srikanth.
yeah thanks. So those who are done you can leave.
Thank
Yeah,
you.
sir, I had
I
like
think
that
Anirban
query.
has a question lined up. Yes.
Yeah, thank you, Ganga Prasad. Thanks.
Yeah, because I am also in queue now. So once you're done, then I will ask.
अच्छा
Thanks, man.
Yes.
ओके या थैंक्स। एंड आदित्य मुझे ये नहीं समझ में आया मैं क्या करूं, मैं खरीद लूं क्या आपके लिए?
And sir,
नहीं सर आप
sir, you listen to Anirban question, sir.
ओके या ask Anil.
Sir, it was that
Aditya, Google कर ले भाई.
p value thing, like c
अच्छा
dash
अच्छा
c
p
double dash.
value right? Okay let me get. अरे I don't have the co-host access man. I didn't ask for co-host access. See, can you do one more thing? अभी तो सेशन रिकॉर्डेड है, एक बार फिर से एक बार उस रीजन पे जाके एक बार चेक करोगे? नहीं तो वी विल डिस्कस बाद में आल्सो. सो p वैल्यू इज बेसिकली
Sir, एक बार just आप verbally बोल तो भी चलेगा. I have that thing written down, jotted down.
okay you have noted it down right?
Yeah.
Let me, so you just be at the graph now. Have you opened the graph? That C1 C prime
Yes,
C
yes.
double prime.
Yes. So t is on the right hand side. Next to t is the c double dash. Then there's a c dash, and
C.
on the left of c dash is c.
Yeah. So what we said is, suppose you have some C. So for
Sir,
that
just one
C,
second. The question was to find the lowest significance level alpha.
yes, lowest significance level alpha. Yeah.
And we are trying to understand like why lowest or highest or whatever it is.
Yeah, correct. So if it is C, so you see there is C. I draw a line, straight line, vertical line, and I said I marked it as C. And the right side of it, I have given some blue.
The rejection zone.
Rejection zone, or the right side area. If you compute the area under the curve,
that's alpha. I get that.
It's actually the alpha. It's actually equal to alpha.
Got it.
Correct? So I just move my C to right side and I just move to till C prime. So another value. It's not C. It's greater than C. Okay. So when I move to C dash, so there I have seen the right side area under the curve, which is denoted as red lines.
But it's this C dash area will be less than that was under C.
C dash
area would be less than what was under C. So probability of alpha, that is our type 1 error, would be less under C dash than it had been under C.
Under C.